Welcome, my students. Our today's discussion is regarding work powered energy, that is, energy in action. Now, we have to know what is work. For performance of work, some force should be applied. Without application of force, no work will be done. So, the first condition for work done is to apply force. On application of force, if some displacement of the point of application of force takes place towards the direction of force, then some work is done by the force. And the work is measured by the product of force and displacement. So we can write work equal to applied force into displacement. That is displacement of the point of application of force. So in spite of application of force, no work can be done if no displacement of the point of application of force. Say there is a heavy body and you are applying force on this body. If force is applied, but displacement is zero. No displacement takes place in spite of application of a large quantity of force. Then the work will be F into zero, that is zero. So some displacement of the point of application of force. Displacement of the body, that means displacement of the points of application of force should be taken place. So work is measured by the force and displacement, its product is the work done. Now the displacement should be towards the direction of force. Actually, work equal to force into displacement into cos theta. Now what is theta? Theta equal to angle between force and displacement. So when displacement is done towards the direction of force, then work equal to force into displacement into cos 0 degree. Say you are applying force on a football and displacement of the football takes place towards the direction of force. Then the value of the angle is 0 degree. So work equal to F into D into cos 0 degree. That is equal to F into D into, cos 0 degree equal to 1. That is equal to F into D, force into displacement. So the work done will be measured by the product of force into displacement. So work can be defined in the following manner. After applying a force on a body, if some displacement of the point of application of force takes place towards the direction of force, some work is done by the force. Now, if you are walking with a suitcase in your hand on the horizontal path, so this is the direction of line of force you are applying on the suitcase against the gravity, and the displacement of that suitcase takes place towards this direction. This is displacement, direction of displacement, and this is direction of force. So the angle between the force and displacement is 90 degree. I am again stating that you are walking with a suitcase in your hand at a horizontal path. So the force is in vertical direction and the displacement direction of displacement is horizontal. So the angle between them, theta equal to 90 degree. Now what will be the work done in this case? W equal to F into S into cos 90 degree. Here displacement is taken as S. That is equal to F into S into, cos 90 degree equal to 0. That's equal to 0. So the work done will be 0 in this case. So we can write that if the force acts perpendicularly with the direction of displacement, then the angle between the force and displacement is 90 degree. Then no work will be done by the force. So if the force acts perpendicularly with the direction of displacement, no work is done despite occurring some displacement. This force is called no work force. F into S into 0, that is 0. So though displacement takes place, but as the displacement is perpendicular to the force, so no work is done by the force, and this force is called no work force. So keep in mind that on application of force, if no displacement takes place, then no work will be done, but that is not no work force. No work force, the question of no work force arises when on application of force some displacement takes place, but the displacement is perpendicular to the force, that is the force acts perpendicularly with the displacement. So no work force can be defined as the force which acts perpendicularly with the direction of displacement, and in spite of occurring some displacement, no work is done by the force. This is called no work force. This is about no work force. Now we have to know some work in favor of force. When work done is in favor of force, work done in favor of force. That is, if some displacement takes place towards the direction of force, then some work is done by the force. If we kick a football, if we push a table, if we push a chair, then some work is done by the applied force, and this is work done in favor of force. If an apple falls from the tree to the ground, an apple is falling towards the ground, this work is done in favor of gravitational force. The work is done naturally by the gravitational force. But if you are pushing a body on application of force, displacement of the body takes place. In this case, work is done by the applied force. So this is work done in favor of force. Now, work done against force. Work done against force. As an apple falls on the body, then work done in favor of force. But if you lift a body from the ground, then work done against gravitational force, work done against gravity. And this is work done against force. If you are riding a cycle against the air current, then work done against force. Hence, for work done against force, a new force should be applied. Keep in your mind, without application of a new force to overcome the force against work done, you have to overcome the against force and to apply a new force. Then work will be done against the force. This is work done against force. Now we have to know the units of work. Units of work. We will determine the unit of work. Number one, in CGS, force into displacement, that is time into centimeter. So unit of work in CGS system should be 9 centimeter, and this is known as arg. So what is 1 arg work? On application of 1 dyne force, if 1 centimeter displacement of the application of force takes place, then 1 arg of work is done. And in SI, Newton into meter. That is, the work done is Newton meter in M. That is known as joule. Its short form is capital J. You can recall that when you are writing a unit, then it should be started with small letter. But if it is named after a person, its abbreviated form will be in capital letter. But in other cases, it will be in small letter. So, in CGS system, the unit of work is arg, and in SI system, the unit of work is joule. Now, the relation between joule and arg. 1 joule equal to 1 Newton into 1 meter. That is equal to 10 to the power 5 dyne into 100 centimeter. That is equal to 10 to the power 7 arg. So this is the relation between joule and arg. 1 joule equal to 10 to the power 7 arg. And there are some gravitational units of work. Gravitational unit. Number 1, in CGS it is gram centimeter. 1 gram centimeter equal to 980.6 arg, that is 980 arg. And in SI it is kg meter. 1 kg meter equal to 9.8 joule. So these are the gravitational unit, gram centimeter and kg meter. If a body of mass 1 gram is lifted against gravity up to a height 1 centimeter, then the work done is 1 gram centimeter. And its weight is 1 gram weight. 1 gram weight equal to 980 centimeter per second square. 980 centimeter per second square. And it is lifted 1 centimeter. So 980 arg of work is done. And 1 kg weight, 1 kg means 1 kg weight means 1 kg into 9.8 meter per second square, that is 9.8 Newton. And when it is 1 meter lifted, 9.8 Newton into displacement 1 meter, 9.8 joule of work is done. So this is the relation between gravitational unit and absolute unit. Now, in the next part, we will go through power. Thank you, my students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.